Okay, class, let's get started. Remember, you can answer my questions or ask me questions on your own using the text feature here in Zoom. So yes, text me your answer or your questions. Just a reminder, my notes will be in Google Classroom by the end of the period. So what I suggest is instead of copying this right here, um, by the end of the period, my notes will be in Google Classroom. You can print them out or just copy them, okay? Give me a minute. Okay, very, very important. Any of the missing assignments you have, you can turn in by this Friday, by the 6th. After this Friday, I will not take late work anymore, okay? What that means, if you have any assignments from September, October, the last day you can turn in is by the 6th, by this Friday, okay? You can still turn in November, November, December work, okay? But I will no longer take September, October. So you have a deadline till this Friday to turn it in. Gotta be careful because you know what? You don't have a second chance. So make sure you look at your picture before you submit. Some of you are turning in pictures that are too dark or too blurry, okay? If that's the case, try to fix it because I want to give you another chance to turn in, okay? You only have one chance to get it right, and that's it. If you mess up, it won't happen anymore. Okay, now, give me a minute. Okay, so today I'm about similar polygons, and here's the definition of similar polygons. Okay, any two polygons are similar if their corresponding angles are congruent. Remember, corresponding means in the same position, and congruent means that they're equal measurement, and we use a symbol for congruent. Okay, the measure of the corresponding sides are proportional. What proportional means for us is one fraction. Sorry, one fraction equal to another fraction. So one fraction will be equal to the other one. And for us now, similar is the little squiggly line. Okay, that means similar. So you want to say that a triangle ABC is similar to another one, you say triangle ABC is similar to, let's say, triangle XYC. So this symbol means similar, okay? Now, the assignment is already online. I'm gonna do some of them as examples for you. I'm gonna do problem number one. And they ask the state if the polygons are similar. Okay, and for similar, there are two conditions. Condition number one is corresponding angles. That means in the same position. So corresponding angles. I'm gonna put these symbols of angles and are congruent. Remember, corresponding means in the same position. So they gave me this angle is 50. and they gave me this angle is 50. So they're corresponding, and congruent means they have the same measurement. So the angle they gave me is corresponding and congruent. Okay. There's a way you can find out what the other angles are, but we have not covered that. Okay, so I'm only going to use that angle. Now, the thing is, corresponding sides are proportional. Sides and proportional means this. One fraction equal to the other. Okay, so the way you do it, give me a minute. Okay, so the way you do this problem is there are 4 sides, so that you need 4 fractions. 1, 2, 3, 4. Now, the way you do it is pick any of the polygons, pick any of the shapes. Let me pick this one and pick a side inside, and I pick the top one. So what I'm gonna have in the numerator is the first polygon, and the second polygon will be in the denominator. So the way you do it is this side corresponds to which of these sides, okay? Just say the answer out loud or take the answer.
20.
20. So the top corresponds to 20, okay? Then let's go to this side. The right side is 18. This right side corresponds to what side over here?
24.
24. Now let's go to the bottom side. The 15 corresponds to what side on the other polygon? This 15 corresponds to what side over here?
20.
20. And lastly, this 18 corresponds to whom on the other polygon? This 18 corresponds to what side over here?
24.
24. Now, the question is this fraction equal to this one? Well, the way you look at it, all the numbers are different. So no, they probably they're not the same, right? But here's the way you have to do it. Take the 15. You're gonna use factoring trees. So factors of 15, what 2 numbers can I multiply to give me 15? Can I use 1 or cannot use 1 or 15? Can you do it? 2 numbers that multiply together to give me 15, but you can use 1 or 15. Can you do it? Yes, that'll be 3 and 5. Good. Now factor again. 2 numbers that multiply to give me 3. Can I use 1 or 3? Can you do it? Factors of 3. Can I use 1 or 3? The answer is no, so that number is prime. Prime means cannot be factored, that's it. Factors of 5, can I use 1 or 5? Can you do it? No, that cannot be done either, so that's prime. So you're done. Once you get prime numbers, you're done, that's it. Now take the next number, 20, and give me the factors of 20. Can I use 1 or 20? Can you do it? Yes, you can do it. The number will be 4 and 5. Factor of 4, can I use 1 or 4? Can you do it? Yes, that'll be 2 and 2, very good. Factor of 5, can I use 1 or 5? Can you do it? No, so that's prime already. Factors of 5 of 2 cannot use 1 or 2. Can you do it? Okay, no, that's prime also. So you have to keep going to get all prime numbers, okay? Next number is 18. Factors of 18, can I use 1 or 18? Can you do it? Two numbers that multiply to give me 18, can I use 1 or 18? 2 and
No, because it's 3 times 6.
okay. Hold on, I'll do 26 right now. Okay, let me do 2 and 9. 2 is prime already, we know that. Factors of 9, can I use 1 or 9? Factors of 9, can I use, okay, 3 and 3. And 3, I know it's already that is prime. Now, when I ask factors of 18, somebody said 3 and 6. Now, will this person get a different answer than this person? Let's do this. Factors of 18, she said 3 and 6. And 3 is prime. Okay. Now, factors of 6 cannot use 1 or 6.
For 6, can you use 3 and 2?
Yes, 3 and 2 or 2 and 3.
But
So
then for 3,
these will be 2 and 3, and those are primary. Now, compare the answer that we got over here and the answer we got over here. 2, 3, 3, 3, 2, 2 is the same number. Okay, so no matter what path you take, you're gonna get the same answer. Okay, whether you use 2 and 9 or 3 and 6, doesn't matter, the answer will be the same. Okay, now after 18 should be 24. Factors of 24 cannot use 1 or 24. Can you do it? Good, I got 6 and 4. Remember, 3 and 8 would also work, 12 and 2 would also work. Doesn't matter, the answer will be the same. Factors of 6. Factors of 6. 2 and 3. And those are prime, we know that already. Factors of 4. That'll be 2 and 2. And 2 is prime already. Okay, so this is something similar to what you learn in middle school. Okay, and you stop to get all prime numbers. Okay, now what you're gonna do, you're gonna do the following. Instead of 15, I'm gonna put the factors of 15. I got 3 and 5. Put them in order from smallest to biggest.
wait, so for the prime number, like you need it to solve these types of problems?
You'll make it easier. Okay, you can also do it with cross multiplying. But you know, cross multiplying 15 and 24 will give you a very big number. Cross multiplying 20 and 18 would also give you the answer, but that's a bigger number. So the way I see it is, this is easier work than cross multiplying. Okay, let me finish this and I'll show you how you cross multiply. Okay. Now, factors of 20, I got 2, 2, and 5. So instead of 20, I put 2 times 2 times 5. Factors of 18, I got 2, 3, 3. Factors of 24, I got 2, 3, 2, 2. Put them in order. That'll be 2 times 2 times 2 times 3. Now, I'm not going to do the other ones. And let me tell you why. This is exactly the same thing as this over here. Okay, so no need to do it because I want to get the same numbers. Now, once you do that, is If you have the same value, the same number top and the bottom, you can cancel it. So the first fraction, can I cancel anything? Remember, if the top and bottom numbers are the same, I can cancel them. So I can cancel the 5s. They're the same. Can I cancel anything else? No, that's it. Next fraction, can I cancel anything? Okay, I can cancel the 2s
And the 3?
and the 3. Now notice what you have. You have a 3 on top. Denominator is 2 times 2. What is 2 times 2?
4.
4. Now, on this one, you have a 3 in the numerator. Denominator is 2 times 2. What is 2 times 2?
4.
So guess what? They're equal. Here they look different, but once you reduce a fraction, they're the same. So therefore, your answer is yes, they're similar. If they're proportional, then they're similar. Okay? Now, there's another way you can do it without doing all the factoring. And some kids like it, some kids don't like it. Okay? How you do it, to me, doesn't matter as long as you get the right answer. And this is how you do it. Okay? You probably, I don't know if you remember this from math 1, there was something called cross multiplying. So here's how you do it. Okay, you have 15 over 20, and then equal to 18 over 24. Now the way they show you in math 1, they will tell you cross multiply this way and put the answer right here. So cross multiply 15 multiplied by 24. Now cross multiply this way and put the answer right here. That'd be 20 times 18. Now I don't know about you guys, but that's a hard multiplying. Okay. Now, if the numbers are equal, then this will be equal. Okay, what I recommend if you're gonna do that, use a calculator. What is 20 times 18? Anybody use a calculator, please? 20 multiplied by 18. Say your answer out loud or text to me, okay? Give me a minute.
360?
Okay, so 20 times 18 will be 360. Now do 15 multiplied by 24. Anybody?
The same.
What do you get?
It's
The
the
same.
same answer.
It's the
Same
same thing. So you could have done it this way, or you could have done it this way. The problem with this, that you're multiplying very big numbers. Okay, whether you do this method or this method doesn't matter. You pick the method you like. Okay, but one thing to notice is yes, on both of them you get that they're equal. So on the questions that I give you, you can do it this method if you want to, or you can do this method. Both of them will give you the same answer. Okay. Now, what is similar? Similar means the same shape, but one is larger than the other. Okay. So imagine this is the mommy and this is the baby. Okay. Same shape, very similar, but one is larger than the other. Okay. Now, next example. And it's the same thing is, are they similar, yes or no? Okay. Now, There are two conditions. Condition number one is corresponding angles have to be congruent. Remember, corresponding means in the same position. Corresponding angles. Angles, I'm not gonna write the word angle, I'm gonna put the symbol for angles, and that means that they're congruent. So corresponding means in the same position, okay? So for example, this is the upper right angle. Down here, the upper right angle will be this one. So they're corresponding, they're in the same position. Are they congruent? Congruent means that they're equal. Are they equal to each other? Yes or no?
The angle?
Yes.
Yeah.
They have the same measurement.
No, isn't one of them bigger?
Wow. What does this red square mean?
90-degree angle.
90-degree angle. What is this?
90.
So are they equal?
Yeah.
Yeah. Now look at the bottom right angle. Are they congruent?
Yeah.
Now look at the bottom left angle. Are they congruent?
Yes.
Now look at the upper left angle. Are they congruent?
Yes.
So in this case, you know what? All the corresponding angles are congruent. All of them. Now I have to check for the second condition. The next condition is, you guys know what this means? That means the word on top. Corresponding sides are, and proportional means one fraction equal together. Okay, so corresponding sides are proportional. Now there are 4 sides, so I need 4 of them. 4 fractions, 1, 2, 3, 4. Now, pick any side. Let me pick the top one. So the top side of this polygon corresponds to what side over here? The 16 corresponds to what side over here?
12.
Yes. 16 is the top side, so the top side and bottom will be 12. Now let me pick the right side. 28. The right side of the big polygon corresponds to whom over here?
15.
Now pick another side, let me do the bottom. 16 in the first polygon corresponds to whom over here?
12.
12. And then 28 corresponds to?
15.
Now, notice that this is repeating already. So I'm not gonna check these ones, I'm only gonna check the first one. Because this is the same as that, okay? Now, I'm gonna take the number 16 and I'm going to do the prime factors. What can I multiply to give me 16? Can I use 1 or 16? Good, I got 2 and 8. 2 I know that is prime. What about 8? Factor of 8, can I use 1 or 8? Factors of 8, can I use 1 or 8? Good, 2 and 4. Because what you should know already, 2 is a prime number and 3 is prime. Factor of 4, can I use 1 or 4? 2 and 2, and what you should know by now is 2 is prime. So I'm done with 16, they're all prime numbers. Now factor of 12, can I use 1 or 12? Say it out loud or text to me. Okay, I got
2 and 6.
Well,
Oh, never mind.
2, 3, and 4, either one will give you the answer, okay? Now, factor of 3, well, 3 is prime already. 3 is prime. Factor of 4, can I use 1 or 4? Good. 2 and 2. And 2, I know that is prime. So I got 16, I got 12, now let's do 28. Factor of 28, can I use 1 or 28? Factor of 28, can I use 1 or 28? Good, I got 4 and 7. Factor of 4, can I use 1 or 4? 2 and 2, and I know that 2 is prime. Factor of 7, can I use 1 or 7?
No, isn't it just one?
No, it cannot be done, so it's prime. So now you should know 2 is prime, 3 is prime, and 7 is prime. Now, next number is 15. Factors of 15 cannot use 1 or 15. Two numbers that multiply to 15 cannot use 1 or 15, 3 and 5. And 3 is prime, we know that already. Factor of 5, can I use 1 or 5? No, cannot be factored, that is prime. So what you should know already is 2 is prime, 3 is prime, 5 is prime, and 7 is prime. Okay, now I'm gonna rewrite the fraction with the prime factors. So instead of 16, I'm gonna put in 2 times 2 times 2 times 2. Factor of 12, I got this, put them in order from smallest to biggest. So it'll be 2 times 2 times 3. Factor of 28 will be, do you guys see the mistake right here? Oh no, that's right. That'll be 2 times 2 times 3. Notice you only write the numbers that you circle. Notice I didn't put 8. Okay. 12, and there's another here. It's not 12, it should have been 28. So factors of 28, write only the numbers that you circle, is 2, 2, and 7. 2, 2, 7. And factors of 15, I got 3 and 5. Now look at each fraction. If you have the same value, the same number, top and bottom, you can cancel it. On the first fraction, what can I cancel? Okay, I can cancel a pair of 2's. Can I cancel anything else? I can cancel another pair of 2's. Can I cancel anything else? That's it, no more repeating. Now look at the second fraction. Can I cancel anything?
No.
No, they're all different. So what I have here is 2 times 2 is 4. Denominator is 3 in there. 2 times 2 times 7. That'll give you 28. 3 times 5. Now, are these equal to each other? Is this fraction equal to this fraction? So therefore your answer is similar. And the answer is they're not similar. Okay. Remember, when you have a circle with a line through it, that means no, not similar. So that's how the other problems are. Okay. Now there's another type of problem, and I have an example for you guys, and that'll be example number 9 on the homework. Okay. So here's a question. It's different. It says the polygon in each pair is similar. Find the missing side lengths. So now they told me they're similar. Okay. So I need to find the missing side. So the way you do it is you do the following. In this case, they told me they're similar already. So because they're similar, I can do this. Because it told me they're similar already. So they told me that. So they're similar, they're proportional. Now, which side is missing? Okay, this side is missing. So I like to start with a question mark. Now this side corresponds to what side over here? The question mark here corresponds to what number over here?
18.
18, good, thank you. Now, give me another side that you know right here. The only side that I know is this. So that'll be on top, 6. Now this 6 corresponds to whom over here?
9.
9. Now, I cannot do this because you know what? For factoring, I need a number. And there is no number here. Okay, I cannot do question mark. And then I cannot find out what multiplies to even question mark, okay? The way you do this is you cross multiplying. Multiply this and put the answer right here. That'll give you 9 times question mark. Cross multiply these numbers and put the answer right here. That'll be 18 multiplied by 6, and they're equal. Now, get the question mark by itself. How would I get the question mark by itself? Say it out loud or text it to me. How would you get the question mark by itself? Okay, this is 9 times question mark. The opposite of times would be divide. So you divide by 9. What you do to one side, you do to the other. These will cancel. So the answer will be question mark. What I recommend you do is do the following. Factors of 18 cannot use 1 or 18. What numbers can I use? Cannot use 1 or 18. Okay.
6 times 2.
6 times 2 or 9 times 9.
6 times 3.
Yeah, let's use 6 times 3. Now, factors of 6, can I use 1 or 6?
Can you use 3 times 2?
3 times 2. And we know that 3 is prime already.
Yeah.
3 is prime already, and 2 is prime. Now, to the next number, factors of 6, can I use 1 or 6?
For 6, it's 3 and 2.
Yeah, 3 and 2. And we know that 3 is prime already, and 2 is prime. Now, factors of 9. Okay, that'll be 3 times 3, and those are prime. Now, what I'm gonna do is right here, instead of 18, I put the factors of 18. That gave me 2, 3, 3. That gave me 2 times 3 times 3. Now, what are the factors of 6? 2 and 3. What are the factors of 9? 3 times 3. So the thing to notice is this is 18. This number is 6. And this is 9. Now, if you have the same value, the same number on top and the bottom, you can cancel it. Can I cancel anything? Does anything cancel? Okay, the 3's will cancel. Can I cancel anything else?
No.
Yes. You see that 3?
Oh, yeah.
Can I cancel anything else?
No, because there's no other number in the bottom.
So all you have is 2 times 3, 6, and 2, 12. So the answer will be 12. If you don't like factoring, multiply 18 times 6, which will give you a big number, divide by 9. And doing that will give you 12. Like I said, I rather work with small numbers than big numbers. So if you work with small numbers, the math will be easier. I mean, 18 times 6 will give you a very big number. And then divide by 9. Okay, but either one of them will give you the answer. Like I told you guys, I prefer to work with small numbers than doing big math. Okay, give me about a minute and then the notes will be in Google Classroom. Try the assignment and then after 1 minute, I'll come back and help you guys. Okay, try it, please. Try it.